exercise it, okay, you can make money out of it. But you can also have, things when things are mispriced actually. You can have when things are mispriced. So it's worth something, but you are getting more for the same thing now. You're getting less for the same thing. It's not the opportunity for the other guy. So what are the really fundamental objectives of this course? Number one, construct models. Construct or consider, you can say hypothesize model for movement of stock. Okay? That's the key thing that we do. Second thing, the second question that we want to answer. Does this movement of the stock contain freelance? How did I know that I have an opportunity here? Okay. Does this movement contain freelance? And if there is, how to make money out of it? Okay. But if you are in potential of risk, then how you can prevent it actually? That's good. How should make money out of it? You can do it. Okay. Getting the point? So what we should do in general, that our model does not contain any arbitrage opportunity. That's going to be rational. That's going to make my model a rational model. People are going to believe on it. And the third thing is that if I have something which depends on a stock, like options, I only tell you after the documentary that option can work, option can work for you. It has the risk. Get rid of risk even in some situation. Therefore, if I am interested in a derivative, like a derivative or financial contract, like option, okay, what should be the fair price? Premium. Of by derivative, I mean financial contract. Options. Stock is also available. Clearly available. Where is it? So you see, there can be two loopholes, roughly, where you can expect freelance. Okay? Number one, you can expect that the model that you have proposed contains, shows the indications that okay, there is an arbitrage opportunity in this field. And the second thing is that okay, if there is no arbitrage in the model, the second thing is that okay, if you have an arbitrage free model but you misprice a derivative, you overprice or underprice it, that is also going to allow you to make freelance. So what we want to do is to fundamentally meet with these two objectives. What should be done? How can I know that my model does not contain any arbitrage opportunity? Okay. And if I have a derivative which depends on this stock, okay, then what should be the fair price of it? Okay. In other words, by derivative, mathematically I don't mean anything. I mean some function of a stock. That's it. It's a function of a stock. It's like a betting over the slot. What I want is that either you should have a arbitrage opportunities in your model, or you should have arbitrage opportunities by mispricing them. That's a fundamental. I mean, if you see, till the end of the course, we're going to just do these two things in variety of ways, in different kind of ways. That's what it is actually. The crux of the course. Because if you have both, if you have these two things in your hand, you are in position to do good investments. The risk investments in which the risk is minimal. Alright? Is it making sense? That's the bigger picture. We need to invest in both bonds and stock. Okay? And we want that there shouldn't be any arbitrage opportunity at any instant. Okay. Shall I?
Yes.
Okay, let's begin with. I'll highly recommend to read the first chapter of it. Book that you have read it. If you haven't read it, read it. Okay. It's going to give you the basic formula. It's going to tell you what is the meaning of a derivative, what is the meaning of market term. All financial terms are there. Now we are going to begin with something very simple. In other words, let's begin with the simplest possible model of the market. Okay. If you see what miracle this little Bachelor did was that, like he created or she created, I guess, he created. He, you see, in documentary, it was called as he actually. Okay. So that he created. So he was the first guy who created this complete mathematical model roughly of. He realized that the stocks are random. Okay. There's no way to predict them. And he created a complete mathematical model of financial markets. And he also said that if someone can claim, can basically price this mysterious contract, which is called an option, then we are done. Like you can get rid of the risk in certain situations of transactions. Okay. But he said that I don't know how to price it. Okay, I know that if someone can price it, you can deal with the problem of this. And then people started doing daily bits. And then in the 70s, these two guys came to a different approach than the approach that we are going to do. Okay, but it's really analog. They did a kind of a continuous time approach, model and price option, but they kind of had some assumptions and they drive a partial differential equation. Which is satisfied the price of by the price of option, and they solve it at get a formula. Very easy differential. It's very interesting that that the same equation that equation is also called the heat equation. You'll learn this in police. Okay. Heat equation is a kind of equation which tells you that how the heat is basically, one of the interpretation could be that how the heat conductance is happening in a metallic bar, for example, if you have a bar of finite length and you attach it to the source side. Is going to give you kind of flow of flux of heat, metallic bar, and that heat can be modeled to heat equation. The same equation is telling you that how the values of these daisy options are basically. Anyway, but we're going to do this. easier than to get its equivalent. So we have very fundamental market assumptions. Okay. Number one. Okay, we're going to work under these two assumptions. Number one, trading can be done at two dates. It's like a 0 and 1. 0 is like the inception. Okay. And 1 is like when you go into exercise. So it's like you make investment here and you get the payoff of the investment at the time. Loss of it. At the moment, very simple model. But we want to reach here.
0 and 1 are times, sir.
There are time. Okay. There are dates of trading. And we assume that we have an investment, a risk-free investment, B naught, okay, and a fixed interest rate, for example, R. Then at time 0, then at time 1, what is going to be the B1? B naught times
1 plus R.
This is going to be the value. That's the second assumption. That we are investing in bonds and we are investing B naught. And the second thing is that there is a risk-free asset and there is a risky asset. So the model is talking about risk-free asset and there is a single risky assets. Risky asset involved in this model. Now, why it should be risky? So imagine the value of a stock at time 0 is that's not. It's risky because we don't know that the price is going up or price is going down. We have bought something great. We don't know that the price of it is going to go up or going to happen in the future. Anyway, so we are assuming that there is only two possible trajectories for this stock. So either it can go, it's going to become as one. Right? This is not as one of you, in other words, price of the stock is going to be S1 in case of the scenario where the price goes up. So it's like a U is a scenario that price has gone up. And D is going to be another scenario that price has gone down. What is going to be the second possibility? Where this U and D constitutes what we call probability space. That's what we call probability space. Okay? And it's a probability space, it's going to obviously that if you add a probability of U and probability of the scenario B, or we should get 1. And we're going to assume that if I have to represent, if I have to abstract, then I'll use omega as a symbol. As a symbol. So it's like omega is a scenario and sample. So it could be up and it could be down. So if I have to talk abstractly, I'll use omega. Alright? See basic amount. There are two dates where trading can be done. Okay. We have a risk-free asset. These dynamics are this. There is no other possibility, just one possibility. Okay. And we have a single risky asset, okay, on which you have two possibilities. And these rules and these are like scenarios. Okay. They are possibilities of this somewhere. But and another thing. Now we need to make sure that this guy should be smaller than this guy, otherwise it doesn't make sense. Okay. So you need to give things as part as a number S1, it's a number S B, it's a number S1. So these are numbers. Okay. So this is something known to me. This is something known to me. Okay. But these two things are unknown. But one thing that I know for sure is that this S1 of D is always smaller than S1 of U. Naturally. Yes. Okay. Similarly, we can also assume that this guy is also. This guy is also. Similarly, stocks are also. All these quantities are because I can have some assumption as T is positive and Dt is positive when T is invertible. There is nothing for what we can say that phase is. Stock price cannot be there. And then I have the last assumption. So that's assumption, we can say that's assumption about positivity of the prices. The last assumption is that I can trade. Okay. There's like this assumption about divisibility, liquidity, and short selling, but essentially it means that I can trade these guys, stocks and or the way I like. In other words, yeah, I like. But in other words, that I can trade them in any units. I can buy not only one unit of a stock, but I can buy a 0.25 units of stock. That's not necessarily there. People. Or I can sell 3 units of 3.5 units of stock. So just I can buy and sell in any quantity. Okay. In real world, it's not the case. In real world, it's not the case. Okay, you can buy or sell in a specific line. If you go beyond a specific number, you have to pay more or pay less. Trading costs. We are assuming that there is no cost. Okay. So market is liquid. Market is liquid. In other words, I can trade this constant bond. They are one in any units. Okay. So if I put all these things together, I get concretely important. Like this. That's not as one of you. That's one of T, rise of V naught, value of this, income, plus R, and probability of happening this is T, and probability of happening this is that's our first model. So what we want to do in this model, achieve these fundamental things. Number one, how can I know that there is an arbitrage opportunity in this movement of bond? If I have, okay. So it's like if I am the benefit taker, I think I should be able to spot them. I must be able to spot the opportunity. But if someone else is benefit taker, then I must be able to prevent the arbitrage. How can I must be able to know that okay, that how the arbitrage opportunity can be prevented. Okay, stock is not in my hand actually. I can't do anything with it. Okay, but I can make adjustments here in such a way that if I know that something is coming, I can prepare myself to meet with it. You must be able to know what. And the second thing is that okay, if I have, for example, a financial derivative which depends on this stock option, okay, how can I do it in the fair prices? It does not allow any other system. Okay. So what we are going to do, for example, in second chapter is that we are going to add scenarios. So instead of 2, imagine I have this everything same, but I have n possible scenarios. And we're going to answer the same question. How can I prevent the arbitrage? How can I price a derivative? And then to turn it into the more realistic, what we're going to assume? We're going to assume that imagine now that we don't have 2 dates, but we have a finite number of dates where these things can happen. Then you can ask the same question, okay, in that model, what would be the meaning of arbitrage opportunity? How can I prevent it? How can I price the derivative? What we do? Stand models. Meet with these 2 objectives. Okay. Alright. Let me define some more terms. So it's like first discussion is all about setting up the terminology. Okay? The terms in which we are going to speak. Let me define some more terms. But up to this time we haven't talked about something which is that what is the meaning of investment? So it's investment and opportunity, and what is an investment precisely? Okay. We're not like finance people who can just talk about things and who don't understand that what they're talking about. Okay. So we want to have a very concrete mathematical meaning behind these concepts. So what I mean by investment, okay, are a portfolio. So what is the meaning of a portfolio? The meaning of a portfolio is an ordered pair. Next one. Where these x and the y's can be any real numbers. Why we have this? Because of this assumption. Market is like this. We can choose these x and y that we want. But what is the meaning of x and y? Okay. So the x means the units of bonds that you are trading. X represents the investment that you are making in bonds. Okay. In other words, one bond cost me $10, but I have $20, 20 bonds. So this X represents how many bonds we have. How many bonds I have bought or sold. And Y represents number of units of
Shares.
number of shares of the stock. Stock. We have a single stock, not stocks. That's going to be another term this time. that instead of one stock, imagine I have m stocks here. And I have n scenarios. Okay? So that's my investment in bonds, and that's my investment in stocks. So that's my investment strategy. That's my portfolio. In other words, that's something that I have. Is it making sense? Okay. I will denote this portfolio simply by this will be phi. Okay. Symbol phi. The phi. Now, if I have my investments, it should worth something. Okay. How can I know that I have bought or sold this much number of bonds and this much number of stocks? Yeah. Then the question is how much money I have in my pocket at time zero. What is going to be money in my pocket at time one? So the next thing that I'm going to define is the value of the portfolio. The value of the investment strategy. What should be the value of the portfolio at time zero? Okay, another thing. This is a portfolio that you create at time zero. Okay. Because it doesn't make sense to create a portfolio at time one, because that's an ending date. So you have to do whatever you have to do here. Yeah. In other words, X, Y is portfolio or a strategy that you created. You understand portfolio? So the portfolio is like a basket in which you have usually. Here I have a basket which I have some units of stocks. What is that? Portfolio created at zero. Okay. So what do you think? What should be the value of this? Just as not portfolio, not for just a stock.
Let's not B plus B.
So I have bonds. So that's the worth of 1 unit of bond. And how many bonds I have?
X.
It's not Y. It's not Y.
Exactly. Y. Not the value of the portfolio time. And how about the value of phi? Now this guy is interesting. Because why is it interesting? Because we don't know. Because this depends on the stock action. So in other words, it's going to depend on omega.
Strategy.
It's going to depend on omega. It could be up and down.
XB1.
So it should be
XB1.
XB1 plus
Is a formula.
plus 1 of omega.
It's from
Same. Okay. So, sir, piecewise or S1?
Huh?
Piecewise, S1 of U or S1 of U?
You can write it. Write it, but I shouldn't. So that's how returns on portfolio. In other words, what is your profit? Okay, so most of the time, when we talk of the profit, we try to talk it in the terms of the percentage. How much percentage we have earned at? What is it? For talking about completely. The returns. I'm going to denote this by alpha. Okay. Okay, alpha does not make sense at zero. There's no point of getting any profit at time. Zero. It only exists at time 1.
Yeah.
So what do you think? How can I
V1 minus V dot.
Huh?
V1 minus V dot.
V1 of phi
Minus.
of omega? Obviously, since this is depending on omega, this also depends on omega. With respect to not phi. Okay? And if I want to turn it into the percentage, what I need to do?